This lesson will be using the quadratic equation to determine the solutions of a quadratic expression using journal notes and practice. So first, what is the quadratic formula and what is it used for? So the quadratic formula is the formula for the roots of a quadratic expression. So it's an alternate to solving by factoring. And the formula itself is going to be negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And this formula seems a little daunting at first, but it's actually very powerful, and it actually is made up of things that we already know, right? So the a, b, and c come from our standard form expression. So if we're using this to find the zeros, then we're talking about an a, b, c, which has been set equal to 0 already. So there's a little memory trick that we can use to help us memorize this, and that's going to be a story or a song. Some people like to sing the song. It goes to the tune of Pop to the Weasel, so just ask me during class if you want to hear a rendition of that. But we also have the story, which I think is a little bit more interesting. So the story is that there once was a negative boy who was all mixed up. He went to a radical party, but he was a square. So he missed out on 4 awesome classmates. By the time it was all over, the time was 2 a.m. So different pieces of the story actually tell us something about the formula. For instance, we start with negative boy. That's a way to remember that the formula starts with negative b. And then we said that he was all mixed up. And that tells me that he doesn't know whether or not he's a plus or a minus. So you have negative b plus or minus. And then he goes to this radical party. So that's what tells you to write your radical symbol, or your square root symbol. But the boy was a square. And that tells us that the b inside the radical is going to be a square. So he missed out on 4 awesome classmates. And by the time it was all over, which tells me that I'm going to need to put everything else that came above over something else, the time was 2 a.m. And that's what tells me about 2a. So this is just a little trick that you can use to help you learn the quadratic formula and kind of keep it in your brain. So why do we use the quadratic formula? Why don't we just factor everything? Well, as we've seen before, not everything can be factored, right? Sometimes we'll run into a quadratic expression that the solutions to it are not very easily factorable. And that's where the quadratic formula really comes into play. So the first reason that we use the quadratic formula is because it works in every scenario. Then the second reason that we use it is because it's programmable, right? So a quadratic formula is a formula. It's an algorithm. And an algorithm is something that I can program into a computer pretty easily. If it's just got addition, subtraction, all of my operations on it, then it's something that I can program a computer to do, and a computer can do it pretty well. So that second reason is going to be because it is programmable. So our quadratic formula is actually made up of a couple of components that we already recognize. For instance, our discriminant, which we learned yesterday, was b squared minus 4ac, is the expression that is underneath the radical in a quadratic formula. And the discriminant can tell me something about my roots before I even go to find them. So for instance, if I'm using the discriminant here, I'm going to say b squared minus 4ac, and that's going to tell me something about my roots. And so if I calculate this, I have b squared, which b is 5, and then I have 4 times a times c. So I have 25 minus 4 times a is going to be 8, and then 8 times 3 is 24. So I'm left with 1. So I have a positive 1 here for my discriminant. Well, that will tell me something about my roots right off the bat. So 1, if I take the square root of 1, it's 1. So 1 is itself a perfect square. And if I'm looking at my discriminant table over here, I know that a positive perfect square, the meaning of that is going to be that the roots are rational. If I had a positive non-perfect square, then it would have irrational roots. And the numbers here is that if you have a positive perfect square, it'll be 2 roots. And if it's a positive non-perfect square, it'll again be 2 roots. If it's 0, then we're going to have a single root or solution at the vertex. And then finally, if I have a negative number for my discriminant, then I'm going to have an imaginary root. And the numbers here, you have 1 root if it's a 0, and then you have 2 imaginary roots. Now we'll talk about imaginary roots in a little while. We'll focus on that a lot more tomorrow. But it is important that you're able to evaluate the discriminant in this way. So make sure that you always do this discriminant first before you start doing the rest of the function. All right, so let's work through a couple of example problems. So for our first example, I'm just going to write out my formula real quick. I have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so now I just need to identify my components and plug them in. So for my discriminant, I'm going to go ahead and solve that first. So my discriminant was b squared minus 4ac. All right, so my b was negative 5. So I'm going to say negative 5 squared minus 4 times a times c. So that's going to be 4 times 1, which is 4, times 6 is going to be 24. So it's going to be negative 5 squared minus 24. And so my discriminant will be, interestingly enough, again, 1. All right, so now I know the discriminant, so I can come back to my formula and I can plug in. I have negative b, so I already have a negative 5 as my b, so a negative 5 will be a positive 5 plus or minus the square root of 1 over, and then I have 2 times a. Well, that's just going to be 2. All right, and so this will become 5 plus or minus 1, which is the square root of 1 over 2. All right, and then let's remember, whenever I have a plus or minus sign, I need to break this down into 2 pieces. So I need to look at this as 5 plus 1 divided by 2 is equal to x, or I have 5 minus 1 over 2 is equal to x. All right, so in each of these situations, I want to go ahead and solve. So 5 plus 1 is 6 divided by 2 is equal to 3. So we have x equals 3. And we additionally have the answer 5 minus 1, which is 4 divided by 2. So we get x equals 2. So those would be my 2 solutions. All right, so we can also have a little bit more complicated of a situation. So again, we have an expression here, and it's already set equal to 0, so we don't need to do anything else, and I want to solve at this point. So I'm going to go ahead and start plugging into my formula. First, I'm going to solve the discriminant, which is b squared minus 4a times c, and that's going to be, well, b squared is going to be 49 minus 4 times a times c. So 4 times 2 is 8, and then 8 times negative 11 will be negative 88. So I have minus negative 88. So this is going to be plus 88. So we add these two numbers together, and we get kind of this gnarly number. It's going to be 137. So that's my discriminant. So then I need to take this back and plug it into the function at large, and my function is going to be negative b, so my b is going to be positive 7, so I say negative 7 plus or minus the square root of my discriminant, and my discriminant was 137, all over 2 times a, so that's going to be 2 times 2, which is 4. All right, so this is pretty gnarly looking right here. So 137 doesn't have a very easy root. Actually, it's going to be an irrational number. So because we know that 137 is not a perfect square, we can go ahead and say, okay, well, these are going to be irrational roots. So my two roots are going to be x is equal to negative 7 plus the square root of 137 divided by 4. And we're going to get x is equal to negative 7 minus the square root of 137 divided by 4. So those will be my two answers in the case that I have irrational roots. I won't have to reduce it nearly as far. All right, so go ahead and pause this video and take a moment to work on examples 3 and 4 in your journal. So take about 5 minutes, maybe 6 minutes, and work on those two problems, and then go ahead and unpause this video. Ask Mr. Fox if you have any questions. So the answers to your problems here are going to be that you've got, for example 3, you end up with negative 2 plus or minus the square root, and the discriminant here ended up being 256 over 2. And when we simplify this, this becomes x is equal to 7 and x is equal to 9. If you have any questions about that, go ahead and ask Mr. Fox. And for our other problem, we have 5 plus or minus the square root of 121 divided by 2. And I can't really reduce any of this, so I have x is equal to 5 plus the square root of 121 divided by 2. And I have x is equal to 5 minus the square root of 121 over 2. All right, so your assignment is to work on your quadratic formula worksheet, and before you start solving the problems, make sure that there are going to be real solutions. And I only want you to solve the problems with real solutions, so make sure you use that discriminant to determine if the problem even has real solutions, and then use your quadratic formula to determine if those solutions, or determine the actual value of those solutions. All right, have a wonderful day. Goodbye.